So the first subpart of review of probability theory is nothing but propositions. So in proposition, what they are saying about the probability theory is probability theory typically uses a language that is slightly more expressive than propositional logic. So in probability theory, we are using a language, but it is slightly more expressive than propositional logic. We already discussed in the propositional logic. Compared with it, but with that, probability theory is somewhat more expressible. It gives some more details for us to understand the concept clearly. So compared with the propositional logics, probability theory is somewhat more expressive. Then these propositions may contain the main point is random variables. So here three different types of random variables are there. So before discussing that one, what is meant by a random variable? Always, what is meant by a random variable? A variable which may select randomly. Such type of variables are comes under random variables. But what they are given on this concept, the basic element of the language is the random variable. So we already discussed in the probability theory, it typically uses a language. So in that language, the basic elements is nothing but random variables. So in probability theory, the basic elements are known as random variables, which can be thought of as referring to a part of the world whose status is initially unknown. So in the probability theory, the random variables are nothing but the path. It is some path, but its status is initially unknown. So what is the value of that random variable initially is unknown. So basic element of the probability theory is nothing but random variables. Its initial status is unknown. Okay. For example, cavity might refers to whether my lower left wisdom tooth has a cavity. So cavity might be referred to whether my lower left wisdom tooth has a cavity. So it is a basic random variable. So we already discussed cavity. Cavity means the problem in the teeth. So here the initial, just a cavity is there. What is the status? But afterwards it says the lower left wisdom having the cavity like that. So this is nothing but random variable. So random variable means it is a basic element of probability theory. Initial status is unknown. Then random variables play a role similar to that of CSP. CSP means constraint satisfaction problem. So in our propositional logics, how the constraint satisfaction problem will act in the same manner in our probability theory also, the random variables plays the most important role, and that of proposition symbols in propositional logic. So in the propositional logics and the probability theory, they have some coincidences. Like in propositional logic, how the propositional symbols are there. In the same manner, in probability theory, we have random variables. So, for example, these proportional concepts, that means the random variables, how we can represent it means capital letters are used as the names of random variables. So, random variables are represented in the form of capital letters. Then, however, we still use lowercase single letter names to represent an unknown random variables. So, known random variables are represented in capital letters. Unknown random variables are represented in single letter names in lower case. So single letter and also it is a lower case letter. Such type of representation comes under unknown random variable representation. If you known random variable representation are represented in the form of capital letters. For example, P of A is equal to 1 minus P of negation of A. Like that you are representing. So this is nothing but probability of A. So small letters, unknown, small letters. So unknown variables we are represented in small letters. So each random variable has a domain of values that it can take on. So for example, the domain of cavity might be true or false. So each random variable has a domain of values. So here domain of cavity, what is the values means either it is true or false. Cavity may be available or cavity may not be available. If available it is comes under true. If it is not available comes under false. So always the random variables are depends on the domain of values either true or false. Then these random variables have different types. Random variables types. There are basically three different types are there. In that the first one is Boolean random variables. For example, cavity have the domain true or false. So Boolean values means true or false. So cavity, if the cavity is there or not, cavity is available, then it comes under true. If cavity is not available, then it comes under false. So such type of random variables comes under Boolean random variables. True or false values must be there. So such type of random variables are called as Boolean random variables. It is abbreviate a proposition such as cavity is equal to true simply by the lowercase cavity. Similarly, cavity is equal to false would be abbreviated by negation of cavity. So true cavity is abbreviated by cavity. So it means cavity is there. So cavity is not there, that is represented in the form of here. Cavity is equal to false. It is abbreviated by negation of cavity. So this says cavity is available. This says not cavity, no cavity. So negation means opposite to truth. So false is the answer for that. So we can represent it in this manner. So this is the first type. Then second type is discrete random variables. Discrete. So discrete means one may not have the relationship with other. Separate discrete random variables. So what are those? It includes Boolean random variables as a special case take on values from a countable domains. So, but in discrete random variables, so what are the values we are taken? They are from countable domains. So already we said. So the random variables are contains domains. So in the domains we have values, but those values we are taken from countable domains. So for example, domain of weather might be sunny, rainy or cloudy or snow. So one may not have the communication with others, but how we are taking the domains, countable domains. So what are the values on the domain? It is countable. Such type of domains comes under discrete random variables. So Boolean random variables means true or false. Discrete random variables means we want to keep in your mind nothing but countable domains. So in the domain, the values must be countable. For that we have taken the domain as weather. So in the weather, we have only 4 values countable. Whether the climate may be sunny, the climate may be rainy or cloudy or snow, like this. So this type of concept becomes under discrete random variables, and the values in the domain must be mutually exclusive and exhaustive. So what are the values we have in the discrete random variables? They may be mutually exclusive and exhaustive manner. So this is the second type of random variable. Then the third type is continuous random variables. So continuous random variables means it is a continuous manner. So the values taken from real numbers. So what are the values in the continuous random variables? They are taken from real numbers. The domain can be either the entire real number or some subsets such as from the interval 0 to 1. So the real number may be taken from the real line, or the taken from the interval from 0 to 1, that means 0.1 or 0.2, like that also. So the number may be from real line or may be from the interval of 0, 1. For example, the proposition x is equal to 4.02 asserts that the random variable then acts as the exact value 0.02. So propositions concerning continuous random variables can also be in equivalence such as x less than or equal to 4.02. So this is the concept of third one. So these are the three different types of random variables. Then we are going to discuss the second subpoint in the probability theory. It's nothing but probability theory. So in this concept, we need to discuss three subpoints. One is prior probability, joint probability, and conditional probability. So before going to discuss these three subpoints in the probability theory, just some introductions and atomic sentences concept we will discuss here. Then come to the one. Probability is a way of turning opinions or expectations into numbers. So what is meant by probability? So probability means nothing but turning our opinion or expectations into numbers. So a human expected thing we are converted into a value with the help of probability. What is our opinion or what we are expecting, that things, the human thing will be converted into numbered manner. So such type of way of concept will be called as probability. So probability is a way of turning opinion or expectations into numbers. So this is nothing but probability. That it lies between 0 to 1. That number may lies between 0 to 1. That reflects the likelihood of an event and the chance that a particular event will occur. So what is the chance to occur the particular event means, which is equal to the number of ways that event can occur, and it is divided by the total number of all possible events. So what is the particular chance of particular event occur? For example, in probability, always this is, so we are tossing the coin. That is the main example for probability. How many events can occur means, so number of ways that the event can occur divided by the number of all possible events. So that is the chance of particular event occurred. So chance for particular event occurred is equal to the number of ways the event can occur. The number of ways the event can occur divided by total number of all possible events. So that is the formula in probability theory to getting the chance of particular event occurrence. Then second point is atomic events. Atomic event means individual. Atomic means individual events. So what is this? The notion of an atomic event is useful in understanding the foundation of probability theory. So the probability theory, the basic foundation laid by these atomic events. So what is this? An atomic event is a complete specification of the state of the world about which the agent is uncertain. So atomic event is a complete specification of the state of the world about which the agent is uncertain. So it is a complete specification. It can be thought of as an assignment of particular values to all the variables of which the world is composed. So it is nothing but a particular value. So atomic event means for that event it is expressed individually, and what is the value it generates, it is a particular value of that variable which the world is exposed. For example, my world consists of only Boolean variables, the cavity and the tooth, and then there are just four distinct atomic events. So what are those? So the proposition cavity is equal to true and toothache is equal to cavity is equal to false and toothache is equal to true is one such event. In this manner, we have four different events are there. So this is nothing but atomic events. Then what are the important properties of atomic events? Means they are eventually exclusive at most. One can actually be the case. So this is one. So in that actually one must be the case. So for example, cavity and tooth and cavity and negation of toothache cannot both be the case. So either any one must be the case. The cavity is there and toothaches are there. Either cavity is there and cavity and the toothaches may not be there. In both may not be applied. Any one must be available. Then the set of all possible atomic events is exhaustive. At least one must be the case. Then that is the disjunction of all atomic events is logically equivalent to true. So these are the properties of atomic events. Now we are going to discuss the first point, prior probability. So what is this prior probability? It comes under unconditional. So the unconditional or prior probability. We already said prior probability means before availing the evidence. So in that it is unconditional. So unconditional or prior probability associated with a proposition A is the degree of belief occurred to it in the absence of any other information. It is written as P of A. So A means it is a unknown variable. So such type of values we are represented in small variables. So probability of A. So we don't know what is the A. It is unconditional or prior probability. So that's why we are representing probability of A. So for example, if the prior probability that I have a cavity is 0.1, then we would write as P of 0.1. So P of cavity is equal to true. How much we have believed 0.1, or we can write the same as probability of cavity is equal to 0.1. In this manner we can write the concept. Then it is important to remember that P of A can be used only when there is no other information. If there is no any other information, then only we can use P of A. So why? Because means prior probability means without having any evidence we are finding this probability value. That's why whenever we require there only we want to use this one. If we may not have any information in such a situation only we want to use this prior probability value. So we want to remember this point. When we want to use the prior probability value, that means unconditional value means if there is no any other information in such a situation only we want to use these types of prior probability or unconditional probability value, nothing but P of A. So as soon as some new information is known, we must reason with the conditional probability of A, given that the new information. If there is no any information, there only we can use P of A. If you have any new information, then P of A must be converted into the conditional probability of A and get the new information. So if you have information, based on that you want to modify the A value, and it is also converted from unconditional to conditional. So it can also use an expression such as P of weather. So already we discussed weather conditions, sunny, rainy, cloudy, snowy, like that. So if you take that one as an expression, P of probability of weather, which denotes the vectors of values of the probability of each individual states of the weather. So in the weather, one state may not be depends on other, they are individual states. So how that expression is given here. Thus, instead of writing the four equations, so we have 4 points are there, sunny, rainy, like that. So instead of writing the four equations, what are those four equations? Probability of weather is equal to sunny, which may have the value, how much the belief value, degree of belief 0.7. So the climate is sunny, how much? 0.7%. Then the probability of P is equal to rainy 0.2, weather cloudy 0.08. Then the probability of weather is equal to snow, how much? 0.02. So instead of writing these four equations separately, we can write in this simple manner. We may simply write probability of weather is equal to 0.7, 0.2, 0.08, 0.02, like this. So this also represented that same concept. Note, this statement defines the prior probability distribution for the random variable weather. So this statement is also represent prior probability distribution of random variable weather. So we will also use expressions such as probability of weather, cavity to denote the probability of all combinations of the values of a set of random variables. So both concepts combination also we can use. So that one we can say as the probability of all combinations. We can combine weather and cavities also. So in that case, probability of weather, cavity can be represented as 4 into 2 table of probabilities. So 4 different concepts are there, and for cavity also we have 2 different concepts, either true or false. So we can represent that one as 4 into 2 table of probabilities. So this is called. So if you combine these two, so probability of weather is one part and probability of cavity is another part. If you combine these two, then we call that one as joint probability distribution of weather and cavity. So this combination will be called as joint probability distribution. That is our second point. Sometimes it will be useful to think about the complete set of random variables used to describe the world. So sometimes this joint probability concept is also useful. So in joint probability distribution that covers this complete set is called full joint probability distribution. If the joint probability distribution covers the complete set, then it is called as full joint probability distribution. For example, if the world consists of just the variables cavity, tooth x and weather, then the full joint probability is given by probability of cavity, tooth A, weather. So this type of probability distribution will be called as fully joint probability distribution. So this joint distribution can be represented as 2 into 2 into 4. Totally 16 entities are there. For cavity, true or false, and for tooth it's true or false, and for weather we have 4 points: sunny, rainy, cloudy, and snowy. So that's why 2 into 4 table with 16 entities are there. So that is the first point, prior probability. In that, the second one is joint probability. So what is this joint probability? Joint probability of the occurrence of two independent entity events is conjunction is as P of A and B. So if two events are combinedly wants to represent, then it is two independent events. So not separate independence, two independent events. If you want to combinedly represent conjunction manner, then it is called as joint probability. Probability of A and B, like probability of weather, cavity. Like that, here also we have taken two different independent events. That's nothing but probability of A and B. This will be called as joint probability and is defined by probability of A and B is equal to, if you are placed and means it comes under intersection. So R means union and means intersection. So probability of A and B is equal to probability of A intersection B, which is equal to probability of A and probability of B. So the probability of A and B in joint probability is defined in this manner. So for example, we toss two fair coins separately. So one for A and one for B. So what is happening? Let P of A is equal to 0.5% of belief, the probability of getting head of first coin. Then there is another coin, second coin is also tossed. How much percentage we have the getting head that given here? The probability of B, which is equal to 0.5, probability of getting head of second coin. So the probability of joint probability getting head on both the coins is probability of A and probability of B is equal to probability of A into probability of B, which is equal to probability of A is equal to 0.5 into probability of B is equal to 0.5. Totally we have the chances of getting hit on both coins is 0.25. So these type of calculations we already done in the mathematics in probability concept. Same will be repeated here. The probability of getting head on one or both of the coins, that is the union of the probability P of A and B is expressed as, so already said. So and means intersection, R means union. So if you want to get both coins means then it will be given as probability of A or B, which is equal to probability of A union B, which is equal to P of A plus P of B minus P of A into P of B. So this is the formula. So this is the probability formula for P of A into A and B is P of A into P of B. This is the probability of P of A or B, which is equal to P of A union B, which is equal to P of A plus P of B minus P of A into P of B. So 0.5 plus 0.5 minus 0.25, which is equal to 0.75. So example for joint probability distribution. So given table. So joint probability of A dash. So B dash and A dash. So this is the values. Then probability of A is equal to probability of A and B plus probability of A and probability of B dash. So which is equal to 0.20 plus probability of B 0.26, which is equal to 0.85. So probability of A and B, probability of A and B 0.20 plus probability of A and B dash 0.65. That's why we are getting this value. Then probability of P of A and B plus P of A dash, which is given like this. Probability of A and B 0.20 plus probability of A dash B 0.12, which we are getting, adding these two, we are getting these values. So this is nothing but the joint probability distribution example. Then these are the points of joint probability. Then the third point in probability theory is conditional probability or posterior probability. Unconditional probability comes under prior probability and conditional probability comes under posterior probability. So what is this conditional? It relates the probability of one event to the occurrence of another. So the probability of one event is related to the occurrence of another event. So if you want to occur one event means it relates to another event. It is nothing but conditional. If you want to find out one thing, it depends on another thing. And what is you find out, it is useful to find out another one. It is nothing but continuous probability. One is depends on another. That one is depends on another. In this manner, what is the probability is there? It comes under conditional probability or posterior probability, that is given here. It relates the probability of one event to the occurrence of another event, that is the probability of occurrence of event H given that an event is known to have occurred. So if you want to occur event H, we want to occur, already we want to know about the event E, because to achieve this one we want to know this one. So the probability of event H is nothing but the hypothesis given the occurrence of an event E, nothing but the evidence is denoted by probability of H divided by E and is defined as in this manner. So probability of H divided by E is equal to the number of events favored to H which are also favored to E divided by the number of events favored to E. So we want to know one thing means we want to know in before of another thing. So it comes under hypothesis and evidence. So to calculate that one, this is the formula for continuous probability. So this one we can simply say as probability of H and E divided by probability of E. So this is nothing but the conditional probability. So once the agent has obtained some evidence concerning the previously unknown random variables makes up the domain. So prior probabilities are no longer applicable. So prior probabilities are no longer. Why? Because means in prior probability the random variables are unknown. So for the long period or for the longer applicabilities, prior probability is not suitable. In such a situation, only the suitable concept is conditional or posterior probabilities. So for that we are using this one. So prior probability is not suitable for all the applications. In such a situation we want to use posterior. So the notation used is P of A by B, where A and B are any propositions. This is can be read the probability of A given that all we know is B. So P of A by B we can read in the form of the probability of A given that all we know in B. So to find out the A we want to know B. So conditional probability with multiple evidence. So how it is? So in the conditional probability, evidence means last P of E is the evidence. So if there are multiple evidences are there, then what about the conditional probability? It is given here. If there are n evidence and one hypothesis, then the conditional probability is defined as hypothesis means what we want to know. So evidence means what we know already. Based on this one we are finding. So n events are there and one hypothesis are there. Based on that, how we are going to define the conditional probability means like this. So probability of H, one hypothesis divided by number of evidences E1 to En, which is equal to P of H and number of evidences E1 to En divided by probability of evidences E1 to En. Like this we can find out. So this is nothing but the conditional probability of multiple evidences. Then what are the drawbacks of joint probability distribution? Three different disadvantages are there. One is the full joint probability distribution can answer any question about the domain but can become interactable large as the number of variables grows. So fully joint probability distribution gives any answer in the domain, but if the domain is grows largely, then it will face some difficulties. That is the first drawback. The second one, the time and storage requirement for such computation become impractical as n grows. So if it is growing into the large, the joint probability distribution is grows to number of values, more number of values, then the timing and storage requirements may not be computed. It is impractical. So furthermore, specifying probabilities for atomic events is rather unnatural and can be very difficult unless a large amount of data is available from which to gather statistic estimations. So to providing the values for atomic events is also unnatural for the two very difficult large amount of data. If the data is large, then it, always the probabilities also face problems. So these are the drawbacks of joint probability distribution. So in this review of probability theory, we need to remember two things because we have 2 points, more sub points. One is propositions and second one is probability theory. In propositions, we need to remember two things: random variables and types of random variables. In types of random variables, we have three different types. One is Boolean random variables, discrete random variables, and continuous random variables. These are the three different types of random variables. Then if you come to the second point, probability theory, here we need to discuss 3 points. Post prior probability, nothing but unconditional probability, and then joint probability, and then conditional probability or posterior probability. So these are the points we need to remember in this concept.